What's up, guys? Welcome back to another video in our series covering the final exam review study guide. We are going to go ahead and jump right into some examples here, taking a look at problem 44. Problem 44 says write the standard form of a quadratic equation that has the root 3i. Remember that if it's a root is a 0, is an x-intercept. All of these things are the same thing. So the root 3i x must then equal 3i. But remember, roots come, or imaginary units come in pairs, imaginary roots. So if x equals 3i, it also must equal a negative 3i, or the opposite of 3i. So we can use this to create some factors. X equals 3i would come from the factor x minus 3i, and x equals negative 3i would come from the factor x plus 3i. Remember, they come in conjugates. So let's just call this equation f of x. F of x just then would then equal the multiplication of these two factors. So now we can go ahead and multiply the two factors. Remember, when multiplying conjugates, you can square the first term. So f of x would equal x squared, and then square this last term. So that would be, and it's a subtraction of the two. So 3i squared, or 3i squared, would become 9i squared. Remember, I squared is -1, so f of x would equal x squared plus 9. And you can solve or check this by solving the equation, and you'd find out that it does have a root 3i. Now in 46, a similar problem, but this time we have a 4th degree polynomial. It has integer coefficients and only one real 0, so no fraction coefficients, and only one real answer, which would be x equals -4. Given that for p of x, x equals -4 and x equals 2 plus I, write the polynomial in standard form. So we know that p of x is going to have a 0, x equals -4, which would come from the factor x plus 4. We also know that it's going to have a factor or a 0, x equals 2 plus I, which would come from the factor x minus 2 minus I. So we get that factor again, trying to subtract 2 and subtract I to get x minus 2 minus I equals 0. So the factor would be x minus 2 minus I. Now remember, imaginary units come in pairs. So if I have an x minus 2 minus I also need an x minus 2 plus I. Now this gives me a 3rd degree polynomial because there are 3 linear factors. I need a 4th degree polynomial without creating an additional real 0 because it only has 1. I can't create any other imaginary units because imaginary units come in pairs, and so that would give me 5 at the minimum factors. But what I can do is I can add exponents to one of my factors. So x plus 4 could be a quantity that is squared. Now I would have 4 linear factors, and thus it'd be a 4th degree polynomial. Now we do have to multiply this polynomial out, so I'm going to square x plus 4, which would be x squared plus 8x plus 16, the square of the first term, then double the product of the two terms and the square of the last term. With x minus 2i and x minus 2 minus I and x minus 2 plus I do need to factor these or distribute these two. So I'm going to go ahead and do that one at a time. X times x would be x squared. I won't show you all this, but I'll just talk it through. So distribute the x. X times x is x squared. X times -2 is -2x. X times I would be positive xi. Then distribute the -2, so I get a -2x, a positive 4, and then a minus 2i. Distributing the negative I would get a negative xi, a positive 2i, and then a negative I squared. I'm running out of room there. I'm going to leave my first set of parentheses, x squared plus 8x plus 16, and then I'm going to simplify my second set. So I only have one x squared that's going to stay. I have -2x and -2x. That would become a -4x. I have a positive xi and a negative xi that would eliminate each other. I already took care of the 2x. I have a positive 4. I'm actually going to combine this with the negative I squared because remember I squared is -1. So this would be like -1 or positive 4, or positive 1. So positive 4 plus 1 would be 5. Then I have a negative 2i and a positive 2i that would eliminate each other. So here are my two factors, and I can distribute again. So there's some a little bit of multiplication here that we have to do. So I'm going to distribute the x squared first. X squared times x squared is x to the fourth. X squared times negative 4x is negative x cubed. X squared times 5 is 5x squared. I'm going to distribute the 8x. I'm going to go ahead and line up my terms here. So 8x times x squared would be 8x cubed. 8x times negative 4x would be a negative 40x squared. Sorry, not negative 40, but negative 32. So negative 32x squared. And then 8x times 5 would be 40x. Finally, I can distribute my 16. So this would give me a positive 16x squared. A negative 64x when I distribute the 16 to the 4x. And then a positive 90 when I distribute the, or sorry, positive 80 when I distribute the 5 to the 16. Hopefully I did all that math correctly. Now, let's combine my terms, and this is going to give me p of x. So I only have one term of x to the fourth. Negative 4x cubed plus 8x cubed would be 4x cubed. That 5x squared plus the 16x squared would be 21x squared minus 32. That would give me a negative 11 x squared. 40x minus 64x would give me a negative 24x plus 80. And so this would be my polynomial for p of x. Now, I'm going to go ahead and check this real quick. I didn't do this ahead of time. I just want to make sure I got the math correct. So the one thing that we can check when we take a look at the graphing calculator, you could solve this to check it, but that would be a lot of work. So we can check this on the graphing calculator by looking for a fourth degree polynomial that we have with only a real zero at negative 4. And so if I go ahead and take a look at the graph, its only intersection should be at negative 4. That occurred twice, so it should be a bounce there. It touches and changes direction, and it does. So I believe that I have done this one correctly. Let's take a look at another example. Problem number 47. Problem 47 says, is x squared minus 2x plus 1 a factor of f of x? And show your work for support. Well, there's a couple of different ways that we can do this. We can look at trying to factor f of x. This is going to be a little bit complicated to do as it's an even termed trinomial, or sorry, even termed polynomial. It's cubic, so we'd want to factor by grouping, but it doesn't work to factor by grouping. But if we just want to know if x squared minus 2x is a factor, I can actually use division. Remember that if a number, or if an expression divides another evenly, then it is a factor of that expression. So if x squared minus 2x plus 1 divides f of x evenly, so without a remainder, then it's going to be a factor. So we're going to go ahead and do the division here. Remember, when we divide, we compare the first terms. So what is negative 2x cubed divided by x squared? That would be negative 2x. Now I take this negative 2x and I distribute it to my divisor. So negative 2x times x squared is negative 2x cubed. I'm going to line that up underneath my dividend. Negative 2x times negative 2x would give me a negative 4x squared. Then negative 2x times 1 would give me negative 2x. Now remember, I subtract these terms from the dividend. So I'm going to change all the signs here. So I'm going to subtract those negative values. So the 2x cubes would cancel out. That's a good thing. And I'd be left with 8x squared. The 2x's would cancel out. So 8x squared plus 1. Now I would want to go ahead from here and repeat the process. So compare the first term x squared to this term here. I'm going to go ahead and leave this as 8x squared plus 0x plus 1. I'll come back to that. You'll see why in a second. So I'm going to compare this x squared to that 8x squared and realize that a positive 8 would be the result of division here. So 8 times x squared is 8x squared. 8 times negative 2 is negative 16. Sorry, negative 2x is negative 16x, and 8 times 1 would be 8. And as I subtract these values, changing the signs, I'd get 16x minus 7. So then I would repeat the process, but 16x over x squared can't be divided evenly. So this would actually be my remainder here at the bottom. So we could say that no, x squared minus 2x plus 1 is not a factor of f of x. And that work shows it, that as we have done the division here, that we have a remainder, and thus the dividend does not divide the polynomial evenly. Take a look at problem number 48. Problem number 48 gets into the analytic parabola. So a parabola dealing with the focus and the directrix. So the problem says a parabola has a focus of 2, 1 and a directrix of y equals -2. Write an equation for the parabola and sketch a diagram or show your work to support your answer. So we could go through the process of deriving the parabola, but I wouldn't necessarily recommend it. Let's actually sketch a diagram here. So let's say y equals -2. This is my directrix. My focus is above that, so it's going to be at the point 2, 1. And then I'm going to have a vertex in between the focus and the directrix. And the parabola is going to open up. So remember, the definition would tell us that the distance from the focus to any point on the parabola is the same as the distance from that point to the directrix. So we could use that to derive the equation of a parabola, or we could actually use the vertex form for a parabola. So really all we need to know is the location of the vertex and how far the vertex is from the focus or the directrix. So my vertex is going to sit on the axis of symmetry. This is a vertical parabola. We know this is a vertical parabola because the focus is above the directrix. And this is a y equals line, so it's a left to right line. So on the axis of symmetry, they're going to have the same x-coordinate, the focus and the vertex. Now my vertex has to be equidistant from the line y equals 2 and the focus where y equals 1. So this would be 3 units in between them. So it's going to be 1.5 units away from each, so -1/2. So again, this whole distance would be 3. It has to be directly in the middle, so 3 divided by 2 would be the distance on either side. This distance we would also refer to as a distance d, which I'll come back to. So this is going to be 3/2, that distance there. Now remember, y is equal to a times x minus h quantity squared plus k. I'll come back to a in a second, but x minus h is the x coordinate of our vertex. So this coordinate would be 2. K is the y coordinate of our vertex, so this would be a -1/2. Now in this equation, a equals 1 over 4d, where d is the distance from the focus to the vertex or the directrix to the vertex, which we found that distance, it was 1.5 or 3/2. And so, my equation for a is going to be equal to 1 over 4 times 3/2, and 1 over 4 times 3/2 is 6. Sorry, 1 over 6. So this equation, 1 over 6 times the quantity x minus 2 squared minus 1 would be the equation for my parabola. In problem 49, it says determine the domain for t of x given that it is equal to f times g of x. So remember back to, this is a function operations question. When we combine functions through any arithmetic operation, multiplication, addition and subtraction and division, the result of the domains is going to be the intersection of the previous function's domain. So for t of x, if I want the domain of t of x, it's going to be, t of x is going to be the domain of f of x and g of x. So what we can do here is I can take a look at what my domains would be. For f of x, x plus 6, this is a root function, would have to be greater than 0. So for f of x, we have to have x is greater than negative 6. So anything greater than negative 6, excuse me, greater than or equal to, we can't have a 0 inside it. We can have a 0 inside of a root. So anything greater than or equal to negative 6 would satisfy that condition. For g of x, anything greater than or equal to 0 would satisfy the condition. So the domain would be the overlapping. So if you took a look at a number line, here's negative 6, here's 0. Anything greater than 0 from negative 6, greater than or equal to negative 6 would be from negative 6 shaded to the right. Anything greater than or equal to 0 would be from 0 shaded to the right. So the overlapping is greater than or equal to 0. You could also write an equation and then graph that equation, and we'll do that here in a second because part B says to write a simplified equation for t of x. So t of x is the multiplication of f of x and g of x. So I can take the square root of x plus 6 and multiply that to the square root of x. Because both of these are square roots, I can multiply together the radicand. So x plus 6 times x would be a distribution. X times x is x squared plus 6x. And again, this is where x is greater than or equal to 0. So if I were to take a look at my function on my graphing calculator, square root of x squared plus, sorry, I pulled that out of the root. I need that in the root. Square root of x squared plus 6x, and look at the graphing calculator, you're going to see a domain here where x is greater than or equal to 0 and where x is greater than, or sorry, excuse me, less than or equal to negative 6. But that's not actually going to satisfy the conditions that we have. If in the graphing calculator I put in the square root of x plus 6 times the square root of x, now you can see that the graph is just greater than or equal to 0. So if we wanted to put it in the graphing calculator, we would want to do the unsimplified version of this to check the domain. In part C, it says to evaluate t of negative 10 and t of 3. Well, t of negative 10 is pretty easy to evaluate here. It's going to be undefined because it has to be, our x values have to be greater than 0, and negative 10 is not greater than 0. T of 3 is also not a difficult thing to find. We can evaluate this by inserting or substituting 3 in for x. And as we do so, we get this rounded answer. So we're going to have to do this by hand. So it's 3 squared plus 18. This would be the square root of 27. So I'll do the square root of 27 off to the side here, which is the square root of 9 times 3. Square root of 9 is 3. So this would be 3, square root 3. So there we can see some of the differences between being careful that knowing that t of x is a combination of f of x and g of x for the domain, which would then change what the evaluation for t of negative 10 is. This looks like a good place to stop for now. We'll pick up more in the next video. As always, thank you guys for tuning in, and I'll see you soon.